Welcome. This video is covering the Chapter 2 lab that's on sapling. So just going over some specific notes how to actually go about the lab, because there's a couple questions in here that are investigations, so you'll actually have to do a separate component that's still through sapling, but I just wanted to discuss it. So when you actually go in and log into your sapling account and open up the lab, questions 3 and 4 are going to be the same type of thing, and you'll see something like this. You'll get some sort of data table and no other information, and what you're going to have to do is click on this link here, and it's going to open up another window, and it's basically telling you that you're going to perform this lab. So you're actually going to do the things that you need to do if you were to do this in a lab. So what we're going to do is we are going to heat up a block of metal, put it in a container of water, measure how much the water level, the temperature of that water increases. Okay. So we're going to have a number of different things that we're going to have to measure. We're going to have to measure the mass of our cup. So literally just clicking and dragging. We'll also need to add some water, so I just click it and sapling adds the water in there. We can move that around as well. Here's our gold block. We can move that around. Up in this top right hand corner is where the drop down menu is, where you can change whichever metal you want to look at depending on what sapling has assigned you. The last question, you're going to choose this mystery here in order to identify what type of metal it could be. We can click and drag the thermometer just the same as we did the cup to measure temperatures, initial temperatures. We're going to have to heat up this block here, so we can turn on our Bunsen burner here and see our metal has increased. So you're going to want to actually move all of this stuff around so that you can get all of the data that you need to do. If you ever need to reset it, just click the reload button. It won't change any of the numbers that it's given you, so you can do that experiment over and over and collect all the data. If you forget a data point, just hit reset and get that data point again. So some notes, the theory, the math behind what you're going to want to do here. So let's talk about the data to collect. The table that's on sapling that you're going to have to fill out, which looks like this, isn't actually inclusive enough for you to be able to fill that out. So there's some extra data points you want to collect, and we'll have to do some calculations before you can actually fill out that table. So you're going to need to determine the mass of the cup in grams. You'll need the mass of the cup and water in grams. You'll need the mass of the metal in grams, the type of metal, so that was that drop down menu. You're going to need the initial temperature of the water in degrees Celsius. You'll need also the initial temperature of the metal in degrees Celsius, but you want to collect that piece of information after you've heated it up. So after you've clicked on the Bunsen burner, the thing with the flame to heat up that metal. So you want the upper temperature. Then what we're going to want is T final, so the final temperature of the metal, which will be in the water. So those are all the data points that you're going to want to collect. Kind of your procedure, a very rough outlined one, is you're going to want to collect your masses. Also, collect your metal type. And to figure out which metal you have been assigned, you're going to want to look at that original question. It's going to tell you which metal you want to look at, so it'll be different for everyone. Once you have that, you're going to want to get your initial water temperature. Then you want to heat the metal. So click on the Bunsen burner. Get the initial temperature, initial temp of the metal. Put the metal in the water. And then you'll want to get the final temperature of the metal in the water. And we are going to assume that the temperature of the water is going to be the same temperature of the metal in the end. So the final temperature of the metal is the same as the final temperature of the water. All right, so that is kind of the experiments that you are going to do. So now let's talk about the results portion. Oops. So the results portion of a lab report, that's where you're going to show calculations. So the data section is just strictly what numbers do you get from the instruments you're using. So what number do you get from the balance? What number do you get from your thermometer? Okay, so no calculations, not even simple ones, are done in the data section. Okay. For the results section, that's where you start showing those types of calculations. Even the simple ones we can show in the results section. Okay, so the concept of what's happening when we place that hot piece of metal into the water is that the hot piece of metal has an extra amount of energy or heat, and that heat is going to leave and go into warming up the water. So essentially the heat from the metal is going to go into raising the temperature of the water. Now, while that's happening, the temperature of the metal will decrease until the water and the metal are at the same temperature. So our basic equation that we're working with here, because we're involving a change in temperature, that's going to depend on specific heat. So the equation from your book that we've been using is heat is equal to the mass times the specific heat of whatever we're looking at times the change in temperature. That's the equation that our book gives us. Now this heat is actually a very general term, and we actually have a symbol for it. It's not used in your book, but Sapling will use it. Some books use a lowercase q. Sapling is going to use a capital Q. Okay, but these all mean the same thing. So we have essentially two equations that we're working with. Okay, coming from this base equation, we have the heat associated with the metal, and we have the heat associated with the water. So we have heat of metal, or Qm, and that's going to be the mass of the metal times the specific heat of the metal times the change in temperature of the metal. Then our second equation we have is the heat of the water, or QW. So we're going to have the mass of the water times the specific heat of the water, which is given, that's 4.18. We use 4.184 in our book. Sapling just uses 4.18. Then we have the change in temperature of the water. So the heat that's lost by the metal is going to be gained by the water. So what that means mathematically is the Q, the heat of the metal that's lost, and we'll take the negative value of that, is equal to the heat gained by the water. So if we plug in our equations here, we'll have the negative mass of the metal times the specific heat of the metal times the change in temperature of the metal will be equal to the mass of the water times the specific heat of the water times the change in temperature of the water. So we need to get basically each of these values. So mass of the metal, you're going to get that from your data. The specific heat of the metal, so specific we want to solve this. Then we have delta T of the water, or excuse me, of the metal, so that's the change in temperature of the water, or excuse me, of the metal. We actually don't have this directly from the data. We will have to do a calculation from it, and that's going to be T final minus T initial. So these need to be both of the metal. T final is the same for both of them. So same for water and metal. This is going to be the initial temperature of the metal. Okay, so we get these two individual values from our data, but we want to do this actual calculation to get our change in temperature of our metal. The mass of the water. Again, we don't get this directly from our data, but we do get our values. We want to take the mass of the cup and water minus the mass of the cup. And these values we do get from the data. So we'll get both of those, do the subtraction to get just the mass of the water. then specific heat of the water, this is given, and Sapling uses 4.18 joules per gram per degree Celsius. Delta TW, this is the change in temperature of the water. And again, this same basic concept as our delta T of our metal. Okay, our T final is going to be the same for water, which is H2O, and for the metal. So that's our final temperature. And then T initial will be the T initial of the water. Then our goal of the experiment you're actually going to do the experiment twice. Okay, the first time the goal of the experiment is to just determine the specific heat of the metal. So that's the first goal. The second goal will be the last question of the lab, and that is to use the calculated specific heat of the metal to identify it. Okay, so you have to repeat the experiment using a mystery metal, and so you won't know what that metal is, so you'll calculate the specific heat just like we've done here, and then you'll look up that specific heat on the table to identify the metal. So the final, your overall calculation, what you're doing is you're going to take your equation here. We are looking for the specific heat of the metal. So what we are going to do is isolate the specific heat of the metal. So we're going to divide both sides by negative mass of the metal times the delta T of the metal. So those cancel out. And we're left with the specific heat of the metal is equal to the mass of the water times the specific heat of the water times the change in temperature of the water divided by the negative mass of the metal times delta T of the metal. Or we can rewrite this, the specific heat of the metal is equal to, there's our negative sign there. We have the mass of the water, the specific heat of the water, delta T of the water, divide that by the mass of the metal times the change in temperature of the metal. And so you plug all those values in just as we've discussed where to find those values, and that's what you'll be able to put into your table for the Sapling homework. So you're going to have your mass of your water and mass of your metal. So you're going to need that value to answer the Sapling question as well as that one. You want the change in temperature for the metal, change in temperature for the water. And then you're going to want the specific heat of the metal that will get entered in here. When you do the mystery one where you're trying to identify the unknown metal that you're given, Sapling will just give you this box and you choose, you type in the identity of the metal. So it'll give you a table and you have to identify what that metal is. Best of luck to you.